All right, today we're continuing lesson 1-1. So we're going to do specifically intersections. So we'll talk about intersections of lines, intersections of planes. Okay, so collinear, what word do you see in the middle of that? What word in the middle? Line, right? So what do you think we're referring to here? Lines, okay? So if they're collinear, that's telling you it's on the same line. Right? So 2 points would be collinear if they are on the same line. So we're going to draw a picture to show that. So if I have points A, point C, and then B and D. Right, so I have 4 points listed here. So if collinear means they're on the same line, what 2 points would be collinear? A and C. All right, what if I want to talk about all 4 points? Are A, B, C, and D all collinear?
No.
No. Simple enough, yes. Collinear, they're on the same line. If they're not on the same line, they're not collinear. Okay? So if we know collinear means they're on the same line, what do we think coplanar means?
Same plane.
Same plane. Right? So looking at this figure, what 2 points would be coplanar? R and S. And then somebody give me an example of 2 points that are not coplanar. Say it again, Taya. Yeah, S and U. Right? 2 different planes, so they can't be coplanar if they're not in the same plane. Simple enough, yes? Questions on either of those things? Anybody still writing that down? Okay. We good? Okay. All right. Next thing we're talking about, lines. So when we talk about 2 lines specifically, there's 2 main ways that we really refer to lines. So if we have 2 lines that never intersect, we call those what? Parallel, right? So we'll call it M and N. Right, so if I have lines M and N and I want to show that they're parallel, we have a symbol. It just looks like 2 bars, 2 parallel bars. All right, so we would say line M is parallel to line N. right? So those double lines just mean parallel to. Okay? Now, what if they do cross? There's two different ways we could talk about lines that do cross. Does anyone know either of those names? Somebody's saying it. Who said it? Say it again. Yeah, perpendicular. What do we know about perpendicular lines, though? They do cross, but it's a specific. They cross and make what? Right angle. Good. Yeah, so perpendicular lines cross, but they have to form a 90-degree angle. Okay, we'll call that A and B. All right, and then just to show that, like we did with line M parallel to line N, we would say line A is perpendicular, and that's like an upside down T, to line B. Okay, we all remember these two things. Yes, not really going over much new on this today. Okay, anybody start writing that down? Okay, now, if two lines intersect but don't form a right angle, they're just called intersecting lines. Okay, and what happens when those two lines intersect? They intersect at a what? True, they do form angles, but they intersect at a single point. Yes. Right? So it's possible, just because we're not drawing this on there, but it's possible, right, that there would be points all over these lines, correct? Okay, but the one that matters to us is where they cross. That point is the one that, like, it's kind of going to be asked you for today, right? So it might give you two specific lines and say, name the point where they cross. Well, it might be point X or point W, something like that. Okay, last one on lines is going to be skew. Now, skew lines are kind of hard because you have to think about it like three-dimensionally. I can't, like, I'm going to draw it, but it doesn't really make sense when I draw it because, again, I can't draw in 3 dimensions on here. But skew lines are not crossing. They're also not parallel. And they're not even on the same plane. Okay, so we're going to draw this on here just so you have kind of an idea, and then I'll show you. Okay, so like what it really looks like is if I have two lines here. So if they're parallel, notice these two are on the same plane, right? If they're perpendicular, they're in the same plane because they're touching. Basically what a skew line is if I move one of them up, right? Now, if this line extends forever, the green line, will it ever cross with the red? No, because they're in two different planes, right? It doesn't even matter if I put them like this. Like if this one's higher up, they look like they're parallel, but if they're not in the same plane, they're not technically parallel. Does that make sense on a skew line? Okay. Again, that one's hard to kind of put on paper because it's three-dimensional and not 2D, but just so we kind of have an idea at least of what that is. Okay? All right, any questions on lines? Anytime two lines intersect, they intersect at a what? Single point. Okay? All right, real quick, let's go planes, and then I'll let you do some work together. Okay, so parallel planes, think about like the two opposite walls in this room, right? So the walls on my left, walls on the right, those two planes are going to extend forever. They're parallel because they're never going to touch, okay? So when we think about parallel planes, we're going to think about opposite walls. Okay, and just like I labeled line L parallel to line M or whatever, I can do the same thing here, right? So I can say plane R is parallel to plane S. Okay, so if I know parallel would be like opposite walls, what would be perpendicular in this room? Yeah, any two walls that intersect, right? So the front wall and the right wall, or the front wall and the left wall, okay? So adjacent walls are going to be perpendicular. Now that one's a little more difficult to draw. Okay, but if you kind of draw like one square or rectangle, something like that, and then we're just going to extend off of one side. Okay, and then we'll just put a right angle right there. Okay. So, same thing here. If I have R and S and it shows that right angle, then I know that they would be perpendicular. If that right angle isn't shown in the corner, are they perpendicular? No. Okay, we'll talk about that in just a second. So, same thing, we'll say plane R. How do I show perpendicular? What symbol? Good. Upside down T. So, plane R is perpendicular to plane S. All right, last one and we're done. Okay, so just intersecting planes means they're not necessarily 90 degrees, right? So does every wall in every room always form a 90-degree angle? Yes or no? Every single time? No, not always, right? Most of the time, sure. But not every single time is that going to form a 90-degree angle, right? So like if you had a room that instead of is a rectangle or a square has 5 sides or 6 sides, those walls aren't going to meet up at 90-degree angles. Okay? So, same idea. We're just going to have two kind of going away from each other. Okay, so we know we don't see the right angle in the corner, so it's not 90 degrees. What do these two things when they meet up form? So we talked about two lines meet at a point. Two planes would meet at a what? What's this right here? Somebody said it. Jordy, was that you? What is it? A line, yeah. Sorry. Now, didn't we talk about how to make